In this first video lecture, we'll start with the prerequisites of the subject, Mechanics of Solids. The code is 2130003. Before starting the content, we'll go through the learning objectives. So after watching these video lectures, you will be able to recall the concepts like system of units, laws of motions. You will be able to define force, centroid, stress and strain, and you will be understand the relation between stress and strain. So these are the learning objectives that can be cross checked after watching the video lecture, that whether they are being verified or not. So starting with the our syllabus of Gujarat Technological University, these are the prerequisites: system of units, laws of motion, basic idea of force, concept of centroid, fundamentals of stress strain in their relationship. So we'll try to cover this concept in this video lecture. Starting from the system of units, we already know that these are the basic 7 units which governs the next secondary units. So the unit of length is meter, unit of mass is kilogram, for temperature it is Kelvin, time second, amount of substance the unit is mole, for luminous intensity the unit is candela, and for electric current the unit is ampere. From these fundamental units, there are many hundreds of units can be derived. So these are some examples: that unit of volume is cubic meter, unit of density is kilogram per cubic meter, unit of velocity is meter per second, unit of force, that is mass into acceleration, so kg meter per second square, that we call Newton, unit of energy is kg meter square upon second square, that is joule, and unit of pressure is pascals. So we are totally aware of all the basic fundamentals and secondary units. The second and the most important laws of the mechanical engineering or physics is laws of motions. These are Newton's first, second and third law. These are the original words of Newton, written in Latin language. In our language, the Newton's first law of motion says that every body continues in a state of rest or uniform motion unless and until it is compelled to change that state by some external force. So in simple words, that an object that is in rest will stay at rest, and an object that is in motion will not change its velocity unless an external force is acted upon that. So that is Newton's first law. What Newton's second law says, that acceleration of body is proportional to the impressed force takes place in the direction in which force acts. So higher the force, more the acceleration; lower the force, lower the acceleration. So it is directly proportional, right? This third law of Newton says that for each and every action there is always an equal and opposite reaction. So that is Newton's third law. The next an important concept is of force. We already know what the force is. We know the physical meaning of force, but the basic definition says that the action of one body on another body is described as force. It could be any action. What that force does is it changes or tends to change the state of rest or motion of the body. So if body is at rest or motion, this force will try to change that state of that body. So it will either change or tends to change. The next concept is of centroid. Centroid is nothing but the mean position of all the points in all the coordinate direction. So these two examples given over here are of 2D. So in that triangle, this is the centroid. It is a regular shape. The second example is of irregular shape. So the centroid of this irregular shape is over here. We'll study it further in the module 2, that is CG and MI, center of gravity and moment of inertia. So to calculate this point, the centroid, there is an analytical method as well. You can calculate it by balancing method if it is in physical term. The next concept is resistance to deformation. So listen carefully, that when a material is subjected to external load, it undergoes deformation. So if this is a body, any material, it is subjected to either compressive load or tensile load, it will deform. The shape will be changed. But against that deformation, the material will offer a resistance. So material is deforming because of force, but the material doesn't want to deform. It will offer a resistance which tends to prevent the deformation. So it will create a resistance against the deformation. So resistance to deformation, and that resistance to deformation is known as stress. So stress is nothing but a resistance offered by body against the deformation, right? So this should be clear that load or force, it is applied to the body. Load is always applied externally to the body, but stress is always induced inside the material of the body. So the force is being applied, but whatever the stress is generated in the material of this object, this is induced. It is not applied externally by us or by any other system. It is induced automatically inside the body. So stress is induced and force is always applied, right? How to calculate stress? Here a simple cylindrical bar is given over here and a tensile force is being acted. So if F Newton is force acting upon it, and A is the cross sectional area of the cylinder, it a uniform cross sectional area, then stress can simply be calculated as force upon area. So this is how the stress is calculated. Next concept is strain. So whenever the force is applied, of course the deformation will be there. Up to small or large extent it will deform. So the deformation or change in length is delta. So how the strain is calculated? Basically strain is change in shape or size of the object due to external load. So whatever the change takes place in the body, it is called strain. The calculation of strain is equal to delta upon L. What is delta? Delta is change in length. The original length was L, but after the application of external force, now the length is delta. So change in length upon original length. This is called strain. So strain is nothing but the change in shape or size of the object due to external load. That is the relation between stress and strain. So right now I would request you to pause the video at this point and just think that could there be any relation between stress or strain? Now you know what is stress, you know what is strains, then can there be any relation between it? So pause this video for a minute, think of it and then go to the next slide. So what the relation says, that stress is directly proportional to strain. So higher the stress, more the elongation or strain. So the constant is modulus of elasticity. It is the property of material that we'll understand in the next upcoming chapter in the module 3. This is the graph of stress and strain. So at up to a certain point, the stress is directly proportional to strain. That point is called the limit of proportionality and it is called elastic region. But after that, in the plastic region, this equation, this sigma, the stress is directly proportional to strain. This equation is not being followed in afterwards. So it is followed only up to limit of proportionality. So after watching this video, you should be able to answer these 5 questions. Pause this video and go through the questions and try to answer the questions by yourselves. If you have any query, meet me personally.